Here's another way of another type of running services, which is called daemon services. Daemon services we all also heavily use at Auto One, but it's more for operational reasons. So these are also long running services, but they are running on each EC2 instance or ECS container instance. So they are, for example, used to basically run things like Telegraph, which is a metric collector, or file beat, which is a log collector. So when these things are coming up, like ECS instances, since they are also like transient in nature, they are coming up and down. What we need is that on each of these like EC2 instances, we want to deploy like we always want to ensure that okay, this our operational things like a log collector or a metric collector is always there, and for that daemon services come in handy because using the daemon services, we make sure that all the time there is basically these collector agents are running, and we don't have to worry about like okay, a new instance is coming up, so we have to start all of these agent services ourselves. No, we just define this as a service, and we say that okay, we are introducing a daemon service. This daemon service will basically collect the logs from, and this must be running on each of these nodes. And when we want to make a new deployment, let's say we want to upgrade FileBeat, we just basically upgrade it from one place, and then ECS takes care of basically updating all of the containers running across the platform. Does this make sense? Yes. Okay. Cool. One. Okay. Let's look at what the task definition is. So task definition is a blueprint for containerized application. So a task definition, the first, it allows you to basically define your containers. Um, yeah, so it can be like it has a lot of configurations. We probably won't be going into a lot of that, but let's look into some of the configurations over here. The first thing you will notice is that the task definition is a JSON object. So and this JSON object is an array. So with each object being a container. So over here, we just see one container over here. So this is the one container, like from over here to over here. But this could also be like we could also have multiple, as I said, like multiple containers inside a task. Um, and with each of these objects, then task definition is expecting certain parameters. So some of them are required and some of them are optional. So for example, things like name. So name is a required parameter. It's called, okay, what is the name of this container? So over here, it's just called Python. Then there's an image. So what image should be used for that container? CPU and memory. So how much CPU are you expecting to for this container? Memory, also how much memory do you want? Essential. Okay, so as I said, like you could have like multiple containers inside a task definition. What essential means is that if this container is essential to the task, meaning that if basically this container dies, should the entire task die, or should it basically keep on living? So if this is set to true, then if that container dies, then the task is failed and it's basically recreated elsewhere or on the same node. But if it's set to false, then basically if that container dies, the task ECS will not basically restart the entire task. Port mapping. So port mappings is like, okay, what allows you to map your container port to the host port. So saying that, okay, you have a Nginx, for example, container, and it has an internal container port of 8081. So you want to expose this to the host port. So this is how you define the port mappings. Normally, we do not define the host ports. We let ECS pick up a random port because we do not have like the luxury of knowing beforehand, like, okay, how many services are we going to run on a cluster and how many containers each of these services will be running. So what we do is that we just leave the host port as empty, and then basically ECS picks up a random port, so whatever is available, and yeah, so that we don't have to basically keep track of, okay, service X a container, first container of service X will use the port 8093, and then container 2 of the service Y will use port 9142. No, that's too much to manage. So we just let the ECS pick up random port. Mount points, volumes, these are configurations for allowing you to basically mount some storage. You probably would have learned about them in your previous session. Log configurations allow you to ship your logs away from the containers and into things like CloudWatch or other drivers that AWS offers. Environment variables are environment variables that that are exposed into the container for your application. Secrets are the secrets maybe things like, okay, you want to put like database secrets or some other secrets that you want to expose and do not want to put it in like plain text in the environment. Docker labels are just applied to are labels that basically apply to the Docker container. Um, that's your, I don't know, operational things decide how to basically handle that container, for example. Any questions at this point? Let me know if I'm going too fast or too slow. Okay, cool. Okay, anatomy of the ECS cluster. So over here, basically, let's look again into a cluster of a typical ECS cluster. So everybody of you probably knows what a region is and what a VPC is. So in a VPC, we have multiple availability zones, which availability zones are like data centers from AWS, and within these data centers, we run like multiple EC2 instances. These EC2 instances, when they register themselves to the ECS cluster, they become like EC2 container instances. So which means that, okay, they would basically now run ECS tasks. They do this by running what's called an ECS agent on them. But what you see over here is that these EC2 container instances are running like different tasks. So task 1, task 2, task 3. And what these tasks are then defined by the task definitions, and these tasks can be part of one service or multiple services that EC2 instance does not know, but this is an abstract is a configuration that's abstracted away from an EC2 instance and handled purely by ECS. So what happens is that when basically, let's say, an ECS service gets a request to run a new task, it has to make a very important decision, and that decision is to, okay, where do I run this task? So it has to pick and let's say it gets like a request to run task 4 of whatever service. Then it has to pick a EC2 container instance, and this decision is basically taken by what we call as placement strategies and placement constraints, and also by the CPU and memory reservations. But we'll talk about it a bit in the next slides. Okay. Finally, before we go into a bit more technical into how does scheduling and placements take place. There are two ways of running your services. One is called the EC2 instances that we showed in the previous slide over here. But there's also something called Fargate. So Fargate is a serverless way of running your EC2 your tasks. So with this, we do not have to spin up the EC2 instances ourselves. But AWS does it for us, that it just takes a task definition and runs like this on the compute power that they have. So we don't have like the luxury of SSHing into that instance or basically having to manage those instances. But yeah, this is something that we do not use. Maybe you use it in a few services for very interesting reasons, but typically what we use is the EC2 flavor of ECS. Any question? Okay, let's move on. Okay, coming back to the topic of placement strategies and constraints. As I said, coming back into this slide, when a new task comes up, an ECS service has to make a decision of, okay, where does it place the task? It does that by first looking at the it has to do two things. So first, it has to look at what the strategy, and this is defined on the service level. So there are three kinds of strategies. So first is the spread, which means that it would a strategy of spread tells the ECS to spread the task of that service across all the available container instances, right? So if you have, let's say, five EC2 instances in a cluster or container instances, and you have eight tasks of a service, then then basically you will have like three of them running a task and then two of them running two tasks. So it's basically a best effort thing. It tells the ECS agent or ECS service to basically spread all of your tasks across the cluster. Bin packing. Bin packing is another strategy. This tells the service that they should pack the task first on one container instance and then move to the next one. So if it has like five EC2 instances available, then it would filling it up one by one. Random, basically, as the name says, it's random, so it can pick up any EC2 instance. Constraints. Okay, so the key difference between a strategy and a constraint is that strategy is something that's best effort, but constraint is always like this is always ensured. So meaning that if you have, let's say, a placement strategy of a spread, and as I said, like, okay, you have five EC2 instances and eight tasks, then some of them will be running more than one task. But in case of basically you have like something like, okay, distinct instance, now basically you will not have more than five tasks running because your infrastructure only has like five EC2 instances. This is something that's always ensured. So in case of basically, if this is not for some reason, if ECS is not able to ensure that, it will not basically boot up a task.